Hello, my name is Nick and I'm Applications Engineer in the SEMCAD team. I will now be presenting some selected features of the SEMCAD X interactive grid engine. We will use the parametric birdcage MRI model to demonstrate the features of the SEMCAD X interactive grid engine. Under the EM Simulations tab, once you assign simulation settings, materials, sources, lumped elements, sensors and boundaries, finally click on the grid icon. It automatically generates a predefined grid. The total number of mesh cells and the number of grid cells in each direction are shown. For the interactive grid engine, there are 5 information windows to aid the user during the process. The grid analysis window shows statistical information for the current grid, like estimated simulation time, total number of grid cells, as well as minimum and maximum mesh steps in each direction. The estimated simulation time is calculated using the estimated speed that the user specifies, based on the experienced performance. The Picker tool can be activated by right-clicking the mouse and selecting Pick Objects. It helps in the interactive selection of different solids directly in the 3D model window. The selected objects are shown in the Picked Objects window. The Grid Engine Settings window allows specialized settings for the interactive gridder, like show or hide grid lines or change visualization colors. Enabling the Lock Grid box prevents that the Grid tool only shows the grid around selected objects. Once an item has been selected in the Grid Regions list, the grid can be refined using slider bars, which dynamically adjust the local and actual scaling factors. The black slider adjusts the local scale factor between 0.001 and 1. The red slider adjusts the actual scale factor for the x-axis, the green slider for the y-axis, and the blue slider for the z-axis. The Grid History window shows a list of cached grid configurations. Each time a grid is calculated due to a change in the grid settings, it is added to the cache. A previous state of the grid can be restored by selecting it in the list. The Grid Regions list contains a list of all items, such as solids, sources and sensors, to which local grid parameters can be assigned. The visibility of the objects can be toggled using the checkbox or directly in the 3D window and then pressing the spacebar. It is possible to copy and paste the local grid settings from one solid to another. The Grid Regions list also highlights the ratio between the actual time step and the maximum time step for each region. Let us take a look at the global grid settings. The global settings for the grid are shown by selecting the background in the list. The overall scale factor is a constant between 0.001 and 1, which multiplies the maximum step and the baseline resolution for all grid settings for all 3 axes. Padding is spacing added to the grid from the bounding box of the model to the grid boundary and can be set automatically or manually. If off is chosen, the grid will be terminated on the boundary of the model. The grid parameters can be specified in fractions of the wavelength of the current region. The unit length can also be set to meters, millimeters, centimeters, and so on. The gang axis field synchronizes the grid settings for all grid axes when checked. The estimated speed field shows appropriate simulation speed in megacells per second, or millions of FTTD cells which are computed in 1 second. This is used to estimate the simulation time in the analysis window. In addition, you can specify the scale factor, baseline resolution, and the maximum mesh step in each of the 3 directions. A baseline is a line generated from the geometry used as a reference for placing grid lines where the grid is generated. Baselines are shown in the grid as green lines and collected from all solid regions, sources, sensors and lumped elements. Green baselines imply that a grid line is enforced at that location in the grid. White lines are normal grid lines between baselines, making the cell boundaries of the non-uniform grid. If the grid that is generated using the default settings is not fine enough, there are various local grid settings which can be applied to the individual solids to add further refinement to the grid. There are 4 different grid modes that can be used to refine the grid for a specific object. The modes are not relevant for grid, regional only, bounding box and the geometrical mode. If not relevant for grid is chosen, the solid is completely transparent in terms of the grid generation. It will still be voxeled and present in the simulation. In regional only mode, no baselines are considered during grid generation. However, the max step field entry is enforced in the entire area. The bounding box mode generates baselines on the bounding box of the solid, and max step is enforced in the entire area. Finally, in geometrical mode, a geometric analysis is performed and the grid is adapted accordingly. This is the most powerful mode. It gives the user the possibility to not only refine the grid in regions, but also within subregions. There are also other quantities like local scale factor, gang axis, and the reference baseline weight. Once the grid has been generated, the model is ready to be voxeled. So right-click on Voxels and click on Make Voxels. Then right-click on Voxels and choose View Voxels to visualize the voxels to check that the discretization corresponds to the model and there are no errors in the grid. This is a very important step since the voxels are the actual input for the solver. Thus, if the voxels are wrong, the simulation will generate inaccurate results. And that concludes our gridding demonstration. I thank you for your attention.